Hey pre-calculus students, today we're going to go over the graphs of secant and cosecant, and it all begins with the definition of cosecant, which is 1 over sine theta. So we're going to go through the unit circle again, and we're simply going to go through all these, but looking for the value of sine of theta. But instead of writing the value of sine, we're going to write the value of 1 divided by sine. So let's start off with the first quadrant. And here we have 0. Of course, it could be 0 or 2 pi. This right here, this will be pi over 6. And here it will be pi over 4. And here we'll have pi over 3 and pi over 2. Okay, so these are all of our angles, and let's go ahead and look at the sine value. Keep in mind the sine value is the y-coordinate of each of these guys on the unit circle if the unit circle is centered at the origin of the xy axis. Okay, so pi over 6. The y value is 1/2. So we're going to write 1 divided by 1/2. And that equals 2. And now we move on to pi over 4. And the y value there is root 2 over 2. So we write 1 divided by root 2 over 2. And that's the same thing as 2 divided by root 2. And for it to be proper form, we cannot have a square root on the bottom. So we're going to write multiply by root 2 divided by root 2. And so that's going to become 2 times the square root of 2 divided by 2. 2's cancel, and that leaves us with root 2. Alright, now pi over 3. The y value for pi over 3 is root 3 divided by 2. So we're going to write 1 divided by root 3 over 2, which is 2 over root 3. Once again, we cannot have a square root in the bottom because it has been ordained from high that proper form does not have a square root in the bottom. So we write root 3 over root 3. And so we have 2 times the square root of 3 divided by 3. And then finally we get to pi over 2 up here. 1 over the y-coordinate. The y-coordinate is simply 1. And so we have a 1 up there. Alright, so we're going to go ahead and keep going. Note that these guys over here will be all related to these guys here. And so all the y values here are positive, all the y values here are positive, so everything over here is going to mirror what you see on this side over here. Alright, so first let's fill in the angles. And so we have 2 pi over 3, 3 pi over 4, and then, of course, 5 pi over 6, and then we get to 1 full pi. Notice for each of these right here, the number in the numerator here is 1 less than the number in the denominator. Okay, so let's go ahead and put these through. Again, we're just repeating the values that we see. 1 over root 3 over 2 is going to be 2 root 3 over 3. 1 over root 2 over 2 is simply the square root of 2. And then 1 over 1/2 is simply 2. Alright, so now we're going to get to this side here and this side here. Let's start over here on the right. The y value is 0. Cosecant is 1 over the y value. That is the sine. And so we get 1 over 0. Well, we've seen how to deal with this before. We simply look at the limiting case and see how it approaches this value from either side. So we draw this out here. You know what, why don't we just go ahead and kind of zoom in so we can really kind of draw it a little bit closer. There we go. And so we call this angle epsilon. That angle epsilon is constantly shrinking. And then we have an angle here. And so this will be a value with this will have an x value of 1. And then we've got, a vanishingly small delta right there. And as a reminder, we're defining these guys as never quite 0, but always approaching 0. That is, they're always shrinking, but they never become nothing. Okay, there we go. All right, so what is it going to be as we get closer from this side? Well, we simply go, 1 divided by the y value, and the y value is delta, so that's going to be approaching infinity. And then we look at it from the other side. Again, we've got an ever shrinking epsilon, and we've got an ever shrinking delta here. This delta is now below the y-axis, so our x and y values will be 1 and negative delta. And so we write, 1, and to make sure that I'm being clear, this one and this one here are not related to each other. Because keep in mind, cosecant is always just 1 divided by the y value. Okay, so we have 1 here. Divide 1 by the y value, which is negative delta, and that gets us negative infinity. So if we approach 0, or 2 pi, if you will, from this side up here, well then we're approaching infinity. And if we're approaching 0 or 2 pi this way, then cosecant is approaching negative infinity. So how you approach this value here, this position, will determine your outcome. Okay. And let's go ahead and look at the other side. Pretty much the same thing. Let's go ahead and zoom in again. We have an ever shrinking epsilon, and here's our point there, and so that point has coordinates. Now it has a coordinate of -1 because it's to the left of the origin, and positive delta. And so the cosecant values is 1 divided by the y value, right? 1 divided by the y value, and so that is approaching infinity. Note that the fact that this was a -1 had no effect on this number because, again, those two numbers are not related. The fact that they're both 1 is just a coincidence. All right, so we've got another epsilon here. This one's slamming in this way. And this has a coordinate, again, -1, negative delta. And so the value here will be simply +1 divided by negative delta. And that means that the cosecant value will be approaching negative infinity. Good. All right, so let's keep going on. Now let's go ahead and fill in the rest of these angles. This is going to be 7 pi over 6. This one will be 5 pi over 4. This guy right here will be 4 pi over 3. And go ahead and get that one too. 3 pi over 2. And notice for each of these, the number in the numerator is 1 more than the number in the denominator for each and every case. Okay. Go ahead and get rid of these. All right, so let's go over the values. Now keep in mind the y values here will all be negative. And so we'll basically be repeating the same pattern we had over here, only instead of being positive, they're going to be negative. So this would be a -2, -√2, -2 square root of 3 over 3, and then down here will be a negative 1. As you can see, there's a positive 1 up there. All right. Note again that the fourth quadrant here, all the y values will be negative. Let's go ahead and fill in the angles. And so we've got pi over 3 with a 5 on top, pi over 4 with a 7 on top, and then pi over 6 with an 11 on top. And so note for all three of these here that the numerator is 2 times the denominator here, take away 1. Alright, so let's go ahead and fill the values. It's going to be repeating this pattern here verbatim. So we have negative 2 root 3 over 3, negative root 2, and then negative 2. Alright, and that's it. We've got all the values for the cosecant theta. Let's go down to the back side of the handout. And we're going to go ahead and plot the graph of cosecant theta. Before we graph it, we're going to plot sine theta with a dashed line. Alright, and so we're going to do the sine theta in this color here just to differentiate. There we are. And then let's go ahead and get our sine theta. And we're doing this to kind of make sure we understand the relationship between sine theta and cosecant theta. Alright, so let's go ahead and take a look at everything. All the values of theta are the same as they were before. I encourage you to fill it out on your own. Refer to the previous handout if you need to. Let's go ahead and fill in all of these values here. And so note that these values here are the same as the values for sine, as they normally are, but above here we're going to refer to the cosecant that we have up here, and note that cosecant, now that goes from 2 to root 2 to 2 square root of 3 over 3, and then to 1. And then for these values right here, those correlate with the cosecant values. Okay, so let's go ahead and start graphing these. You can see if you look up at the unit circle that at 0 we have a discontinuity, and then we have another discontinuity at pi. So let's go ahead and graph those discontinuities. So we have one here at 0, and then another one here at pi. And since we have a discontinuity at 0, that means we also have a discontinuity here at 2 pi. And so note these discontinuities that occur here, here, and here all take place where the sine function crosses the x-axis. Very interesting. Alright, so why don't we look here at pi over 2. We'll start there first, the midpoint here in that little interval. Oh, well, look at there. It's 1. So let's go ahead and graph 1. So it's right on top. Cool. And then what about right here at pi over 6 and right here at 5 pi over 6? Well, when we go up, pi over 6 is 2. 5 pi over 6 is also 2. So let's go ahead and graph those. 5 pi over 6 is here. Pi over 6 right there. And as you can kind of note by glancing, and I do encourage you to verify this when you're writing this on your own paper, we go through all the values in between right here. So let's go ahead and just quickly graph those. Here and here. And then that continues there and there. And so we've got a nice sketch of our graph, and then note that it goes up towards infinity as we get closer to each of these asymptotes. Alright, probably should have drawn that a little bit closer to there. There we go. Just a sketch, not exactly right on the money. Alright, so let's go ahead and take a look at the next part. Alright, and so here we're at 3 pi over 2. And so what's going on at 3 pi over 2? Well, it looks like we're at -1. So we come down here. Kind of interesting how it seems to be following the same pattern it did for this section. So we're at -1 there. And so what's going on here and here? Well, you notice, that right there we're going towards a negative infinity, and over here we're going towards a negative infinity. And so we'll put that right here and right there. And of course, you can kind of plainly see by looking at the unit circle, please verify, that you'll go through each of these points right here. Alright, and so let's just make our kindergarten teachers proud and connect the dots. There we go. And here we go. Alright. And so the pattern should start becoming clear. This first point, that's always going to be right there at 2. And that's going to be shooting up towards infinity. There we go. And then right here, this will be down here. Goes through 2, or -2. And then there we go right there. Alright. Make sure you verify those points on the unit circle to make sure it makes sense. And so here, note that we've got a period here, and then we got to go down here, and then we start repeating the pattern. So note that the length of one period is 2 pi. One period is 2 pi. And that should make sense since it's so closely related to the sine function, which also has a graph of 2 pi. And so putting everything in, we have y equals a times sine of b times x minus whatever our shift is, and then don't forget to add in our vertical shift, where the period in general will be 2 pi divided by b. And I'll have a interactive demonstration of this available for you in Blackboard. And the demonstration will basically look like this. Let's go ahead and switch this to a different color so it stands out a little bit more. There we go. Alright. And so note that we've got in green here the graph of sine. And then we've got the graph of cosecant. And so note that cosecant always touches right there. And we can even verify our a value here and look at how they are related like this. Right? So anytime you're graphing sine or cosecant, you can use the graph of sine as a guide. The reason these two are so closely related is, how do we find cosecant? We define cosecant as 1 divided by sine. So it should make sense that each individual value here is the inverse of all the values down here. And you can see, if we stretch out the period, we have this going on, and there's our horizontal shift, and then of course our vertical shift. Alright, and so note that the a value is related to the distance in between the cosecant y values here, kind of this no man's land, if you will. Alright, I'll have an interactive demonstration of this available for you to look at. I encourage you to play with it, get a good feel for how all this works. Alright, so now we're going to go ahead and look at the values for secant theta. And secant theta is defined as 1 divided by cosine theta. So whereas cosecant was 1 over sine, secant is 1 over cosine. So let's go back up to the unit circle. And let's go ahead and draw everything in green for the cosecant values. Red will be our cosecant value, so go ahead and just circle this. And then green will be our secant values. And just as a reminder, secant is 1 over cosine theta. Alright, so let's go through, let's look at our x values. Right here, the x value is 1. 1 divided by 1 is 1. Alright, and we come over here. The x value here is root 3 over 2, so we'll be doing 1 over root 3 over 2, and we already saw that that equals 2 root 3 over 3 from right here. And then, of course, the x value here is root 2 over 2. And note that will be the same thing. For this point here, we'll have 1 divided by 1/2, which of course is simply 2. Here the x value is 0. So this will end up being 1 over 0, which, as we know, is undefined. So we'll have to deal with that in a similar way as we did with the other asymptotes. Let's save that for after we get all the other values in. Note that over here, x values will be negative, so we'll be repeating what's going on in the quadrant 1 over here, except they'll be negative values. So right here, that will be negative 2. Right here, this will be negative root 2. And then right here, we're going to have negative 2 root 3 over 3. Alright, and then over here the x value is negative 1, so negative 1. Note down here in quadrant 3, the x values will be negative as well, so we just repeat the same pattern as we did in quadrant 2. Right, and then down here will be negative 2. Note once again, x value is 0, so we're going to get a 1 over 0. That's going to cause us to have an asymptote. We'll deal with that in a second. Let's go ahead and finish this off. Note in quadrant 4, the x values are positive. And so we're going to repeat the pattern that we've seen before, but all the values will be positive. So here we have a positive 2, a positive root 2, and a positive 2 root 3 over 3. Okay, so far so good. Let's go ahead and deal with these 1 divided by 0 errors, these discontinuities. And let's go ahead and use the pencil again, but this time I'm going to use a slightly different color. And let's go with a shade of green. And once again, we have epsilon slamming in. And now our values here will be, x will be a positive delta, y is basically 1. And so since secant is 1 over cosine, we're going to have a value here of 1 over delta, which is infinity. And then we look over here, have another epsilon slamming our ray into there. And so our x value now is negative delta, and our y value is 1. Just did not mean to erase that. And so our secant value is 1 divided by negative delta, which gives us negative infinity. Okay? And which makes sense. Note this negative sign here coincides with all the other negative signs on this side. Now let's come down here to the other discontinuity. And as we come from this side here, and there's our epsilon, and we have an x and y values of negative delta and a y value of -1, and we're looking for secant, so we're going to have 1 divided by negative delta, which is negative infinity. And then we look right here, same thing again, teeny tiny epsilon. Our x value is going to be a teeny tiny delta, y value is going to be a -1. Positive 1 divided by delta is going to be positive infinity. Alright, so now we've got all the values for the secant. All we have to do is plug them into the graph to get them. But before we do that, let's go ahead and graph cosine so we can get a feel for how cosine and secant are related. And here's our little cosine wave coming through. Like so. Alright, and all the values are exactly the same as we had up here. Matter of fact, we can even just copy and paste them and just bring them down to here. Alright, so let's go ahead and take note of where all of our discontinuities were. For secant, we had one at pi over 2 here, and then another one at, at 3 pi over 2. So let's come over here. At pi over 2, that's right here. And then another one at 3 pi over 2, which is right here. And again, note that these discontinuities are occurring precisely where the cosine function crosses the x-axis. Or, I'm sorry, the theta axis. And this is going to follow pretty much the same pattern as it did before. Right here, cosine is 1. 1 over 1 is 1. And then we work our way up, 1 over root 3 over 2 will be 2 root 3 over 3. And then 1 over root 2 over 2 is simply root 2. 1 over 1/2 is 2. And as we saw, this will be shooting up like so. And then the same thing on the other side right here. Alright. And then right here, same thing again. Same pattern. And then we come over here to the other side of 3 pi over 2. Again, we're just 1 over each of the individual values you see here. And so 1 over 1 is 1. And then we just keep on going like so. Cool. All right. And so note that the period for this one, we'll start it from over here. And then from there. And then it begins repeating the pattern after that. So note that the length of this period is 2 pi. For the unperturbed secant function, and in general, y equals a times secant b x minus h naught. The x is just a variable, and we could be using theta instead if we wanted to, plus k naught. I'll also have an interactive demonstration for you to utilize. It's very similar to the one for cosecant, so I'm not going to include that in the video, but you will have something to use there. All right, and that's it. I'm at the 30-minute mark, so that's probably long enough. If you have any questions, email me. I am trying to do my best to respond to all of your emails, so anything at all, try and email me. I may not get back to you right away, but I will get back to you as soon as I can. Thank you and have a good day.